All right, today we are going to be looking at finding rational zeros. In the last lesson, we were given a zero or given a factor of a polynomial function and then asked to, like, from there, find the other zeros. But what if we don't know a zero or a factor of a polynomial function? Where would we even start looking for possible zeros? And so instead of just trying any random rational number at all, we are going to be using the rational zero theorem to help us. This is just saying if a polynomial, don't let this confuse you. Anyway, if we have a polynomial that has integer coefficients, so basically non-fraction coefficients, then every possible rational zero has the form p over q, where when we talk about p are factors of a sub 0, which is basically, if you look at that strange equation they have for the polynomial, it's our constant. And q represents our factors of a sub n, which is the leading coefficient. Okay? So what we can do is just look for the factors of our constant, the factors of the leading coefficient, divide, and that gives us the possible rational zeros. And I'll tell you how that makes a difference. So one of the things you'll be asked to do is to list the possible rational zeros using the rational zero theorem. Well, so when we think about p over q, for p, we're going to think about factors of -6, and because that's our constant. And for q, we're going to think about factors of our leading coefficient, which is 1. Well, when we talk about factors of -6, really factors can be positive or negative. So one possibility is plus or minus 1, plus or minus 2, plus or minus 3. 4 doesn't work, 5 doesn't work, 6 works. So our possible factors of -6 are plus or minus 1, 2, 3, and 6. Then we list our factors of q, which is 1. Now, even though it's positive, you really could multiply -1 times -1, right? So notice that these are both, like, all of these have the plus or minuses. Then it says to be sure to simplify. So what that means is just to take every one in the numerator and to divide by the denominator. And since we're dividing by 1, we're just going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay? The reason this is significant, you guys, is because there are like an infinite number of possibilities, and now we've whittled down this infinite number of possibilities to 8 different ones to try. Because what we we're doing the other day is trying like using these values and then dividing by synthetic division. We wouldn't know where to start, but now we would know, okay, it's going to be one of these that I start with. So you wouldn't bother testing 4, for example. You would only test plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6 to look to see if we can find a zero. Okay? Anyway, so let's practice the same thing in letter B. We're just finding the possible rational zeros. So if we think p over q, my p are going to be factors of my constant 10. So that is going to be plus or minus 1. 2 goes into 10. 5 goes into 10. 10 goes into 10. So those are all factors of 10. And then I have factors from the leading coefficient, which is 2 for my q values. So 2, I could multiply 1 and 2 together. So let's simplify. First, I'm going to divide all of the ones in the numerator by 1. So that gives me plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Now we also want to divide everything by 2. So plus or minus 1/2. 2 over 2 is 1, but notice we already talked about 1. Plus or minus 5 over 2. Plus or minus 10 over 2 would be plus or minus 5, which we already talked about. And so these would be the only possible rational zeros. So those would be the only ones that we tried. So I know that still seems like a lot, but now we've whittled down infinity to like 12 possibilities. And so that's pretty significant. One thing to remember is that these are not guaranteed to be zeros. These are not guaranteed to give us a remainder of 0. These are just possible zeros. So how could we find which, if any of these, are actual zeros? Well, just like we saw, we could see if any give us a remainder of 0. Because if it gave us a remainder of 0, then that means that this is a 0 of the function, based on what we talked about the other day in the last lesson, okay? So all we'd have to do is test to see if one gives us a remainder of 0. Now, back in the old days, we had to test every single one to find one that works. But we are going to let you use your graphing calculator to get you started, but then you have to show your work, okay? I can't tell you how many times on quizzes and tests people will just put it in the calculator and you can get it from the calculator. We are using the calculator as a tool to save you time in the long run, but you really need then to show the work to achieve the points that you are given for understanding what's going on, okay? So what we can do to get you started is we can graph it, and then we can look at the x-intercepts in the calculator, and then we can show work to verify, okay? So here's how appropriate work would look for these problems. In example 2a, this asks us to find all real zeros of the function. And so we have a function, f of x equals x cubed minus 4x squared minus 15x plus 18. Let's just pretend, and we don't know where to start. We want to find all the real zeros of the function. Notice if you tried to group, it wouldn't work because you wouldn't have that repeated factor. So this is where we would use this method. So we would think about our possible rational zeros. So we think about our factors of our constant 18. So we have 1, 2, 3, 6, 9, and 18 for our possible factors. And then our Q is our leading coefficient is 1, so the possibilities are plus or minus 1. Now for these problems, you don't have to simplify it like we did up here. When it says to list the possible rational zeros, we do want you to simplify. Here, because we're using it as a tool, you may leave it like this for these problems, okay? But then we need to know which one to test. And again, back in the olden days, like when I went to school, we just had to test. We had to pick one and be like, I think 3 works. And then we would see if 3 works. What we're going to let you do is use your graphing calculator. Let's put this in our graphing calculator. X cubed, maybe go to y equals, that'd be helpful. All right, go x cubed minus 4x squared minus 15x plus 18. So we can put that in our y1. Then we can graph, let's zoom 6 it, and then all we need to do is look for the x-intercepts. And all we want is 1 to get us started, okay? We're just looking for 1 to get us started. So I always read my graph from left to right. And so I notice that there looks like there's a 0 right here at negative 1, 2, 3. Is negative 3 a possible rational 0? And I look and I notice that negative 3 is possible. So that's what I mean by getting you started, okay? So basically, from your calculator, we can see that we think x equals negative 3 works. But now we want to verify, okay? So I'm going to even make that note, but you must verify that. And how you verify it is that we're going to use synthetic division to verify that it gives us a remainder of 0. So we're going to use negative 3 as the x value we're testing. We use 1, negative 4, negative 15 and 18 as our coefficients. And then we use the synthetic division. So we drop it, multiply, and add, multiply, and add, multiply, and add. And look at that. We've verified that is an ugly smiley face. We have verified that negative 3 is indeed a 0. And now that we've verified that from the calculator, we know what's left here. We know that if we were to divide by the factor x plus 3, that we would be left, if we divided that cubic, with a quadratic x squared minus 7x plus 6. Then we can set that equal to 0 to find the other zeros of the function. Because this is super fun, now this is factorable. So we have x and x. The factors of 6 that would work would be negative 6 and negative 1, meaning that my zeros are 6 and 1. So what are all real zeros of the function? Well, from the calculator, we found that x equals negative 3. Then we verified it. And by verifying it, we were able to whittle this quadratic down, whittle the cubic down into a quadratic, which was factorable, and we could find the other values, x equals 6, x equals 1. That's the work that's involved. I totally understand that you can look at your calculator and see that the solutions are negative 3, 1, and 6. But if you want to receive full credit, then I would make sure that you have all of this work involved. You would get 1 point for your answer, but miss all the algebra, the beautiful algebra credit. Okay, so practice that in your homework. Again, we're letting you use this as a tool. Again, back in the day, we didn't even have that. You just had to guess until you found one. So I'm trying to save you pain of guessing all these wrong answers by letting you use your calculator to find one correct one and then going from there, okay? All right, letter C. Let's do the same type of a thing. So we're going to start by finding our possible rational zeros by thinking of factors of 35, which are 1, 5, 7, and 35. And then factors of 1, which is just plus or minus 1. So again, now we have all those 8 possible rational zeros, but let's use our calculator to help, instead of picking something random, of picking one that might work. So again, we could put in x cubed minus 5x squared plus 7x minus 35. And if we were to graph that, I see there's one x-intercept here. 1, 2, 3, 4, 5. Notice that 5 is a possible rational zero. So then, again, so from the calculator, we see that x equals 5, but now we're going to verify that 5 works by using synthetic. So we use our coefficients, 1, negative 5, 7, negative 35. And we verify that it's a 0 by looking for a remainder of 0. And hopefully at this point we're very comfortable with that practice of synthetic division. And we find that our remainder is indeed 0. And so what this then gives us is we had a cubic, so this would be a quadratic x squared plus 0x, which I'm not going to write, plus 7 equals 0. Now this isn't factorable, but we could find the other zeros by solving using square roots. So I would subtract 7, take the square root, and I see that I get plus or minus root 7i. Now these are valid solutions, but the instructions just wanted the real zeros of the function. So because it only wanted the real solutions, I'm going to ignore that as a possibility, which bugs me because I really think you should be able to list it, but whatever. We would if we were to do 5.7, that section. Anyway, so we end up with x equals 5 as our only real solution for letter C. Okay? I think it's good to find those solutions. You guys need practice finding imaginary solutions. So I would go to town, but then realize that if they only want the real solutions, I would just list x equals 5. Okay? These are worked out for you on my classes if you want to look at those. But I do want to talk about what happens if we do not end up with a quadratic when we're done. Let's say we whittle it down and we end up with a cubic, and that's not factorable. Then we just look on the graph and we'll use another 0 from the graph. When you have a quadratic, you might be able to factor. If you're not able to factor, that doesn't mean there's no solution. Remember, you can always use the quadratic formula to help you find solutions also. So like on 1C, we were able to use square roots, but if we have a quadratic that has an x term also, that's not factorable, we could use the quadratic formula. So this says, let's look at letter F. And so let's think about all of our possible solutions, our P over Q. And because 42 has so many factors, and I don't want you to sit through that on the video, let's just try to be cognizant of those when we graph, okay? So let's put this in our graphing calculator. 2x to the 4th plus 5x cubed minus 18x squared minus 19x plus 42. Okay. And then we can zoom 6 it. And technically, if you zoom 6 once, you don't have to do it every time, but so let's take a look and see what we might find. Notice it looks like there might be a 0 at -4. It looks like there might be a 0 at -4. And so if I look at my possible rationals, is -4 a possibility? Maybe we should list these, you guys. Sorry. Okay, so let's list our factors of 42. 1, 2, 6 goes in, so 3 will go in. 4 doesn't, 5 doesn't. So 6 and 7 go in. 3 times 14, 2 times 21, and then 1 times 42. So notice oftentimes, you guys, that these, you know, you can kind of pair them like this. And so once you've found the middle pair, then you can just divide to get the other pieces. Anyway, okay, and then plus or minus 1, plus or minus 2. Okay, so anyway, so now we have those, it'll be easier. So that's why it's nice. So it looks like -4 is a possibility, but notice it's not one of my possible rational zeros. There's no way that I could get 4. So I wouldn't bother, or -4, I wouldn't bother trying -4. -2 is a possibility. And notice that that is a possibility here. So that's why this is helpful, because we could have tried -4, and trust me, it wouldn't have worked. So let's try -2 and see what happens. So if we try -2 with these coefficients, 2, 5, -18, -19, and 42, again, we're going to hope that we get a remainder of 0. Oh, oops. Been sitting too long in this chair giving you guys notes. Welcome to my life. Okay, here we go. So keep going. And I do see that we get a remainder of 0. So I've verified that that is, that negative 2 is a 0. So then let's think about what we would have left. We had a quartic, so that means that I'd be left with a cubic. 2x cubed plus x squared minus 20x plus 21. Now sometimes you can factor cubics by grouping, but I think we can see that if we tried to group, we're not going to end up with a common factor if we were to try to group that way. I mean, each set might have a common factor, but not a common factor. So because we cannot factor, let's look back in the calculator and let's try another one, okay? So it looks like there's one maybe between 1 and 2. So like that looks like 1.5 to me. And so that would, 1.5 is like 3 over 2. And notice 3 over 2 is a possibility, okay? So I'm going to use 3 over 2, but I'm going to use the new coefficients. Don't go back and use the old ones, because if you do, then again you're going to have a quartic that turns into a cubic. We're going to use the coefficients of this cubic, because if we use a cubic, then we'll be left with a quadratic. So that's kind of our goal, is to get to whittle down the degrees to something that's usable. Now I know this is a fraction, but it's doable, because look, 2 times 3 halves, the 2's cancel, you end up with 3. 1 plus 3 is 4. 4 times 3 halves, that would be 12 over 2, or 6. I add, I get negative 14. Negative 14 times 3 halves, so that would be negative 42 over 2, or negative 21. And look. Okay. So what happens is I have this 2x squared plus 4x minus 14 equals 0. That I've now got a quadratic. So that's very exciting. So we could try to factor. I might try to factor out the GCF first. And I get x squared plus 2x minus 7 times 2 equals 0. And then if I try to factor, I can see that there aren't going to be factors of 7 that work. So remember, if you cannot factor a quadratic, we can use the quadratic formula, okay? So we can use these values or these values in the quadratic. I can't ask you what you'd like to use, so we'll use the bigger ones just to practice simplifying. No, we'll use these here. So if you factor out a 2, let's use the quadratic formula for this quadratic. So I'm going to take negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so a is 1, b is 2, and c is negative 7, because that's really the quadratic we're dealing with. So I have negative 2 plus or minus the square root of 4 plus 28 over 2. Let's keep simplifying that. So then I can add 4 and 28 to make 32. I can break that 32 down into 16 and 2. So I have negative 2 plus or minus 4 root 2 over 2. And notice that I can cancel out from all these terms, so I get negative 1 plus or minus 2 root 2. So those are my solutions. So the first one I got from my calculator was that x equals negative 2. I couldn't get a quadratic, so I looked in my calculator again and verified that x equals 3 halves is a solution. And then I use the quadratic formula to find that x equals -1 plus or minus 2 root 2. And so those are my solutions.